I went with a relatively simple robot design. Simple gearing, 2 motors, a 1 to 3 gear ratio, very similar to what the instructions said, except reversed. They had a 3 to 1 gear ratio, speeding the system up. I wanted to slow it down and give me more torque. Simple square design with larger wheels than what was recommended, and I went with an omni wheel in the back to make it easier to turn. Didn't have a whole lot of problems with that. It actually made it easier for me to program because these transitions were smoother. I also added a second tier to the robot to allow me to put the Arduino microcontroller on top and a place for the battery to slide in. The sensors went on top and on front in order to control the robot around. This is the code for the timing objective, where we use timing to navigate the maze rather than sensor integration. So we start with the top block of the code that is in every section of code that we use with this microcontroller. This is used for the LCD integration in order to control the debugging and show us what is happening on the robot without having to use a serial monitor. We can actually see it while the robot is functioning. Next we move into the setup, where we still are essentially initializing the LCD setup. We are putting in titles such as your name, what the project is, a place for the robot status to go, and that's pretty much all we do. And we also, in this setup phase, we attach the motors to show the Arduino where the motors are set up at, what pins. Next, we move into the loop, where we start with integer setup. We tell the Arduino what numbers go with what speeds. It makes it easier for us to remember. We can just type what speed we want to go in words instead of in numbers. It also makes it easier so that if I need to change a speed, I can do it throughout instead of trying to go through each individual line of code and change the number. Getting into the actual loop if statement where the robot is driving, what we're doing is there's an initialization button that I added so that you don't have to cycle the power every time you want to run the robot, and so you can start it whenever you want and you don't have to worry about it starting on you as soon as you turn it on. It checks the button. If the button is pressed, then it will do the if statement. What's inside the if statement is your basic maze pattern, what we know the maze is designed to be. It first drives forward, then turns left, then drives forward again, turns right, drives forward for 4 seconds all the way over the bridge, stops, turns right, and then drives forward one last time and stops indefinitely. The only reason this timing works is because we know what the maze looks like. We know what we needed to design it to. And since we know that, we can time it so that the robot drives through it. This section of code is for the sensor integration for the robot to navigate through the maze. We again start with the basics at the top. Name, title, class, all that good stuff. Then we go into the LCD setup, where we can turn the LCD on, write what we want on it, and tell it what we need to do, so that we can tell that the robot is actually doing what we want it to do. Then we go into the setup, where we are still essentially programming the LCD, putting in titles, putting in the robot status, putting in a place for the robot status to go, and also adding the motors to tell the Arduino where the motors are. We then go into the loop, where we first initialize the integer values. Again, like I said in the last description, that is just to make it easier on me and easier on the Arduino so that I can tell. The communication is easier between me and the computer to tell what is going on, and if it needs to be changes made, I can change it once instead of through each line of code. We then move into the meat of the loop, where we have a different push button setup, that if this push button is pressed, it counts each time it's pressed. So when this push button is pressed, you're not starting something, it means that it's run into something. So what this does is it counts every time it pushes a button. The first time the button is pressed, it stops and turns left. The second time the button is pressed, it stops and turns right. Drives all the way over the bridge. The third time the button is pressed, it will stop and turn right and then stop forever. And driving forward anytime there's not a button.